Okay, this is the similar figures in-class review. So it was the half sheet we did in class on Tuesday, February 19th. I didn't leave myself a lot of room to write. I'll try and squeeze it all in. So the first three questions, 4, 5, and 6, ask us to solve each proportion. All right, so we had three questions we did in class together. If you're in 4th and 5th hour, there was only one question we did because we did the other two on the half day before break. So there should have been 3 we did in class, and then first on this sheet are 4, 5, and 6, which are 3 proportions. So to solve proportions, we need to cross multiply. So we're going to have 4x times x plus 1. So we're going to get 4x times x plus 1, and then 4x times x plus 1. That's going to equal then 3x minus 1 and 2x plus 2. 3x minus 1 and 2x plus 2. Okay, we've got to distribute the 4x. Okay, so 4x times x is 4x squared, right? It's 4 times 1x. 4x times 1x, so 4 times 1 is 4. X times x is x squared. Then 4x times 1 is going to give us 4x. Okay, I'm not sure what method you used here to solve for this, but the way I know is foiling. So first outer, inner last. So 3x times 2x is 6x squared. 3x times 2 is plus 3x. Negative 1 times 2x is minus 2x. And then negative 1 times 2 is minus 2. We can combine like terms. So on this, we leave it 4x squared plus 4x. We get 6x squared. 3x minus 2x is plus 1. This should be 6x. Sorry. 3x times 2 is 6x. Then negative 1 times 2x is negative 2x. Then negative 1 plus 2 is negative 2. Okay, and so 6x minus 2x gives us 4x. And we have our minus 2. So now we want to move everything to one side. We want to simplify as much as we can. So if we subtract 4x squared from both sides, we get 4x is 2x squared plus 4x minus 2. Then we can subtract 4x from both sides. Okay, so all the 4x's are going to end up canceling out. So we're left with 0 equals 2x squared minus 2. Add 2 to both sides. 2 equals 2x squared. Okay, we can divide both sides by 2. We get 1 equals x squared. Take the square root of both sides. We get plus or minus 1 equals x, right? 1 squared is 1, and negative 1 squared is also 1. So it could be plus or minus 1. X equals plus or minus 1. Okay, if this was a triangle or something, though, we can't have the negative because you can't have a negative side length of the triangle or a quadrilateral or a pentagon or anything like that. So if you have a negative, you want to put it in. If you get 2 answers, you want to put them in and just what do you need? So you just want to put them in and check it first. But for just these, where we're just solving for x, you're going to have plus or minus. Next one, so 4x over 3 and 108 over x. Again, cross multiply. 4x times x. Okay, and then we have 108 times 3. And 4x times x is going to be 4x squared. And we get 324. Divide both sides by 4. X squared is 81. Take the square root of both sides. We get x is plus or minus 9. So again, plus or minus 9. But you're going to want to check both those answers if you are doing this on an actual, if it's part of a triangle or some other polygon, because one of those answers probably is not going to work. Okay, but for just this, it could be plus or minus 9. Okay, because you put a negative 9 in here, we're going to have negative 36 over 3. and 108 over -9. So those are going to match up. Those are each going to be -12. But in the +9, they're both going to be +12. Okay. Number 6. A little bit more room to write on this one. Can cross multiply. Okay. There'll be a couple like this on the test where you just have to, they're just giving you proportions and you got to solve them. Okay. It's not attached to any geometry. It's just solve the proportions. Okay. So 3 times, we can cross multiply. 3 times k plus 2. And then 7 times k minus 2. Distribute the 3, so we get 3k plus 6 and 7k minus 14. Subtract 3k, we get 6 equals 4k minus 14, add 14, and then divide by 4. So we get 5 equals. All right, if we plug that back in, we're going to get 7 over 7 and 3 over 3, so we know we have the right answer. K is going to be 5. Number 7 is a pentagon. Okay, it's not a regular pentagon, but it has 5 sides, so it's still a pentagon. So if we look, the question tells us that they're similar, the polygons are similar. And we want to write a similarity statement and find the similarity ratio. This says scale factor. A scale factor is the same thing as the similarity ratio. So first thing I notice is we have 2 pairs of congruent angles. So we have angle C is congruent to angle G, and then angle FDG is going to be, these are vertical. So that's going to be congruent to angle CDE. So we want to write it, it's telling us they're similar. Okay, we want to write a similarity statement. So what are there, 32 different ways we can write the name of the first one? Okay, we can name it however you want, as long as you go around in order. So I guess there's only 10. ABEDC, we could do BEDCA, however you want. I'm just going to try to go alphabetically in order. So let's go with A, B, I'm going to go around clockwise. A, B, E, D, C. Okay. Just went around clockwise. You either pick any point, go around clockwise or counterclockwise. Okay. We know C and G are going to correspond with each other. So my last one was C. I know my last one here is going to be G. And then I know D is going to correspond with D. Okay. But what corresponds with A? So it's basically flipped and rotated. So A is going to correspond with I, right? So if you went, so A is next to C, and we know C corresponds with G, so it's going to be I. Okay, and then we're going to go around in H, F. So H is going to correspond with B, F is going to correspond with E, D corresponds with D, and then C corresponds with G. So this is FDG. Okay. Second part of the question wants the similarity ratio or scale factor. But they're only giving us information on CD and GD, but we know that those two are corresponding sides. So DC corresponds with DG. So that's one of our ratios here. There would be 5 ratios for 5 corresponding sides. And we know DC over DG is 12 over 18, which is 2/3. Okay, and we know since they're similar, all the ratios are going to be equal to 2/3. So AB over IH would equal 2/3. BE over HF is going to equal 2/3. Right? ED over FD is going to equal 2/3. Okay, and then CA over GI is going to equal 2/3. So the similarity ratio, we don't need more than one. We just need one pair of corresponding angles. And we have them, so it's going to be 2/3. thirds. Okay. Number 8. So we redraw the triangles. Okay, so we have PQR, PQR, and then we have PST. Okay, we know PQ is 2x plus 2. We know RQ is 2x. We know ST is 15. PS is going to be 2x plus 2 plus 6. Okay, so the whole thing here is going to be 2x plus 2 plus 6, which is going to be 2x plus 8. Right, 2x plus 2 plus 6 is 2x plus 8. So 2x plus 2 is going to correspond with 2x plus 8. And then 2x is going to correspond with 15. Okay. I'm not going to multiply it out. You guys don't have to either. What's going to happen is we're going to have to end up factoring. We're going to have an x squared term and an x term. So we're not going to be able to solve it quickly. So we're going to have to factor. There won't be any problems like this where you have to factor on the test. So I'm not going to do it. I'm just going to leave it there. But to find the similarity ratio, right, we would have to cross multiply. Well, we can, let's do it. So 2x plus 8 is going to be 15 times 2x plus 2. Okay. So we're going to get 4x squared plus 16x equals 30x plus 30. We want to move everything to the same side. So 4x squared, subtract 30x from both sides. That's going to be minus 14x. And then subtract 30 from both sides. I notice we can divide everything by 2 because everything's an even number. So I'm going to come up here now. So we're going to have 2x squared minus 7x minus 15. And from there, we're going to have to try and somehow factor. 7 and 2. Might have to do the quadratic formula though. So 2x and x. Well, minus 5 plus 3. Okay. So it's factoring. Again, I don't know your box method or whatever is what you would have to use on that one. Again, I don't know the box method, so you do the quadratic formula if you need to. Right, then we can do 2x plus 3 equals 0, x minus 5 equals 0. Subtract 3 from both sides. 2x equals negative 3, divide by 2. X equals negative 3 halves. Add 5, x equals 5. Okay. The negative one is not going to work because it's going to give us a negative side length. So we know our answer is x equals 5, which means our scale factor is going to be 2 times 5 is 10. So we know 10 over 15 or 2/3. Okay, but don't worry about that. If you want to see how to do it, that's how you do it. But you won't have to factor anything. It won't be that complicated on the test. Okay, that's number 8. Number 9. Okay, number 9. So we have parallel lines that we know angle A and angle C are congruent, and angle D is congruent to angle B. That lets us determine which sides are going to be proportional, or which sides are going to correspond with each other. So we know that AM is going to correspond with CM, and then it's the same triangle, so DM is going to correspond with BM. Okay, so we get 25 over x plus 20 and negative 3x over 12. Cross multiply. So I think this one, again, we're going to have to factor. So let's just stop there. This is how you would set up the proportion, though. You'd have to go down, solve for x, and plug it in to find our scale factor. But you won't have to do anything that complicated on the test. So let's just stop there for, well, let's write the, we got to write the similarity ratio too, right? So triangle AMD is similar to triangle CMB. Okay. And then you'd have to cross multiply, factor, solve for x, plug it in, then you can find the scale factor. So don't worry about anything that complicated on the test. 10. So are the triangles similar? Justify your answers. Okay, so we're looking to use one of the theorems if they are similar, and if not, we want to justify why they're not similar. All right, number 10. Again, we have 3 ways to show that triangles are similar. We have angle, angle, side, 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 and side, angle, side. Do we have any information about the angles? We don't, so we know it can't be angle, angle, or side, angle, side, so the only one we can try is side, side, side. In order to look for side, 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 we need to show that the ratios of the corresponding sides are all going to be equal. So we're going to have to create 3 ratios, set them equal to each other, and see if that statement is true or not. Again, the way I would do this is I would look for the smallest numbers first. So we know NL is the smallest number. So 6 is going to correspond with 3. Right? NL is going to correspond with RQ. Okay, the next 2 smallest numbers are 10 and 5. So ML and PQ. That's going to be 10 over 5. And then the largest numbers are MN and PR. So 12 over 6. We notice we get 2, 2, and 2. Yeah. Right, so all the ratios equal 2. Since all the ratios are the same, we know the sides are proportional. Since all the sides are proportional, we know that yes by side, side, side. We know they're similar by side, side, side. Okay, number 11. Okay, we have vertical angles. So angle PTS is congruent to angle QTR. We also know that angle S is 62 degrees and angle R is 66 degrees. Okay, since these 2 angles are congruent, and these 2 are different, we know that angle P and angle Q are not going to be the same. Because 180, whatever this is, right, we do 180 minus that, minus 62, and we'll get something. 180 minus whatever that is, minus 66 will give us something. So we know P and Q aren't going to be equal. And so since P and Q aren't equal and S and R aren't equal, our answer is no. Only one pair of congruent angles. We need at least 2 pairs of congruent angles to say the triangles are similar. 12. Number 12, we have, first thing we should notice is we have parallel lines. If you have parallel lines, you should look for alternate interior angles or corresponding angles. Okay, here we have corresponding angles, right? So we have, here's our 2 parallel lines. We have a transversal. We know corresponding angles are congruent. Here's another one going through those same parallel lines. We know that corresponding angles are again congruent. So that's angle C and angle AED, and angle B and angle ADE. Okay, we also know by the reflexive property that angle A is congruent to itself. But we don't need all 3 pairs. We need at least 2 to use angle. So we have at least 2 pairs of congruent angles. So we know that the triangles are similar by angle, which says if 2 pairs of congruent angles, or 2 pair of corresponding angles are congruent, then the triangles are similar. So that's yes by angle. Okay, we said to skip 13, 14, and 15. You can do them if you want. I'm going to skip them on the video, though. So you don't have to worry about 13, 14, or 15, but they're good problems. If you want to See how much you know. Okay, that's going to take us to 16. Okay, the question's saying tells us the triangles are similar. So if the triangles are similar, we know all the corresponding angles are congruent, and we know the sides are proportional. Okay, so it's asking us to find the similarity ratio. Okay, so do we have any corresponding sides where we know the information for both? Yes, we do. We have FR over dA, which is 4 over 6. We know 4 over 6 reduces to 2 over 3. So our similarity ratio there is 2 over 3. All right. We could find the rest of this on here if we needed to. We know that's 105. We could find the missing angle. We could find the length of dy. We could find the length of ri. The question just wants the similarity ratio, okay, which is 4 over 6. So fi over dy is going to equal 2 over 3. Ri over ay is going to equal 2 over 3. Okay, so 2/3 is the similarity ratio. This first triangle is 2/3 the size of the second one. Okay, if the question said find the similarity ratio of the second to the first, then it would be 3 over 2. 6 over 4 would give us 3 over 2. So this triangle is 3/2 larger than the smaller one. The smaller one is 2/3 of the size of the larger one. Number 17. 17. It's telling us that they are similar. So we know that all the ratios are going to be the same, but we can test that out anyway. So 10 is the smallest number. So it's going to correspond with the smallest side, which is 4. So 10 over 4, which gives us 5 over 2. Okay, just for fun, we can check the other ones to make sure they're all right. So 18 is the middle length. So 18 is going to pair up with 7.2. If we put that in the calculator, we're going to get 1.677 or 1.6667, which is 5 over 2. The largest sides are 20 and 8. And 20 over 8 is 5 halves. Number 18. Okay, it tells us the polygons are similar, and it wants us to find the value of the variable or variables of each variable. Okay. So 18, 2 is going to correspond with 3. So we're going to put 2 over 3. Since we know they're similar, it tells us they're similar, we can set up a proportion. Right? We know the sides are proportional since it says the triangles are similar. So 2 over 3, and then again that's going to equal 6, and 6 corresponds with x. Cross multiply, we get 2x equals 3 times 6. So 2x is 18, divided by 2, x equals 9. So 2 over 3 is is the same as 6 over 9. Both are 2/3. Number 19. Okay, number 19. Let's set up our proportion. So we have a right angle and a right angle, and then we have one arc and one arc. So if we look at the sides that are not with the right angle that doesn't have the arc, okay, that's 9 and 6. So we're going to have 9 over 6. Between the right angle and the arc, we have x plus 1 and 8. So x plus 1 is going to correspond with 8. And then we have the hypotenuse is y plus 2, and the hypotenuse on this one is 10. So y plus 2 over 10. We want to find x and y. So we don't want to have two variables with one equation. So if we can get one equation with one variable, that's ideal. So we can use the first two ratios, 9 over 6 and x plus 1 over 8. cross multiply. We get 72 equals 6. We got to distribute, so 6x plus 6. Subtract 6 from both sides. And then we want to divide by 6, and we get x equals 11. To find y, and we can pick any two ratios we want. So we can either substitute 11 back in and then set that equal to y plus 2 over 10, or we can just use 9 over 6 again. So 9 over 6, y plus 2 over 10. Cross multiply, so we get 10 times 9, and then we get 6 times y plus 2. And that's 90. And distribute, so we get 6y plus 12 minus 12. Subtract 12 from both sides. 78 is 6y divided by 6. Y equals 13. Okay, so we can plug that back in, substitute these back in. 11 plus 1 is, so we have 9 over 6. That's 11 plus 1 is 12 over 8. 13 plus 2 is 15 over 10, which gives us 3 halves, 3 halves, 3 halves. So we know we have the right answers because we know all of those equal each other. Okay, last two, 20 and 21. Okay, are the triangles similar? If so, we want to write the similarity ratio and name the postulate or theorem that we used. If not, we want to explain why they're not. Okay. So here we have one angle X and angle J. The measure of both those angles is 58. So we know angle X is congruent to angle J. Okay. You know, 3 ways are angle, angle, side, 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 and side, angle, side. Okay. It tells us XZ is congruent to XY. And it tells us JL is congruent to JK. So we have, so if we make this X, we know the other one's also going to be X. If we make this Y, we know the other one's also Y. So we're going to get X is to Y as X is to Y. So it doesn't matter what numbers we use. If we use 10, that's also 10. If we use 5, that's also 5. So we get 10 over 5 equals 10 over 5. So since we have isosceles triangles, right, and the angle here is the same, we know that, yes, these are similar by side, angle, side. Okay, and then our similarity ratio, in 6 different ways to name the triangle. Let's just name it X, Y, Z. And that's similar to triangle JKL. Okay. Then number 21, the last one. Same thing, we want to say, are they similar? So we want to look for angle, angle, side, or side, side, side. We don't have any information about the angles. Right, so that's going to eliminate angle, angle, and side, angle, side. Which means we're looking for side, side, side. To show 2 triangles are similar by side, 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 we need to show that the ratios of all 3 corresponding sides are equal. Okay. So if these are going to be similar, the small sides are going to match up. So QS is going to match up with TV, which is 8 over 4. The middle numbers, which are 12 and 5, are going to line up. They're going to correspond, and then QR is going to correspond to TU. They're the 2 longest sides, so 17 over 8.5. Okay, right away we see that these 2 aren't going to mix up, right? That's going to give us 2. This one's going to give us 2.4. That one's going to give us 2. But 2 does not equal 2.4, so we conclude they're not similar. And the question wants us to explain if they're not similar. So the explanation here is the sides are not proportional. So all sides are not proportional. If you know everything on this review, and you know everything on the review you got before break, I think you should be good for most of the test. I think there's 1 or 2 tricky questions, but I think we've gone over everything that you should know most of it. So I think you guys will be good.